So to get back to our ongoing example, we created a function that allowed us to see the n-gram context for a word in a text. But what we would like to see is we'd like to see all of the m-gram contexts for that word if it appears multiple times. And we can do this by creating a pure function version of our function that we created just now, and then mapping it across a list of positions that we get from positions. Let me show you what this looks like for the first one here, and then I'll talk you through it. So let's start with the second part. If we ask for the position in sample text words of the word nymph, we know that that's going to return position 271. We've seen that before. It's going to return that to us in a list. If we take word position to n-gram and give it the argument sample text words, slot, and 4, and then don't forget to add the function, if we create this pure function, what this pure function does is it's going to give us a word position to n-gram that outputs a 9-gram for whatever word position gets substituted into here. In this case, it's simply the word nymph. Now, nymph only occurs one time, so we haven't really bought ourselves much with this example. But we know that the word life occurs twice, so if we do the exact same thing with life, it gives us both of those cases, again 9 grams, where the word life is in the center. And if we take the output of that and we use table form formatting, and here I've changed the word yet again, this time to sleep, we can begin to see something that looks a lot like the keyword in context display that we created in a previous lesson. But the important thing about what we're doing right now is that in the keyword in context code, we had to go through our entire text and generate all the 7 grams, or in this case we're using 9 grams, we would have had to generate all the 9 grams for the whole text in advance. We're not doing that here. What we're doing here is we're searching for the positions in which a particular word appears. We're searching, and then we are outputting the n-gram contexts of that word. So we don't have to pass partition across our whole text in order to compute this. We find the word, and then we look to its left and we look to its right to compute a local n-gram. Here's one more example. In this case, I'm using the vertical bar here which is shorthand for the command called alternatives. I'm using the vertical bar to search for one of 2 options, either 2 in lowercase or 2 capitalized. And you can see now that our single display has given us a list with both of those forms in it. So if we keep capitalization in our text, we might want to be able to search for alternatives like this. Now there's another command which can be used to index a string, and that is the command string position. So remember, what we've been indexing so far has been words in a list. We've been indexing a list with the position command. What string position does is it reaches inside of a string, not in a list, but into a string, and it gives us the position of particular things in that string. So for example, if I start with sample text, this is the original soliloquy as a whole string. It hasn't been split up into a list of strings. It's a single string. If I use string position in that, I can get an output that looks like this. It shows me that the first instance of the word life occurs from character position 613 to 616. And the second location of the word life occurs from character position 967 to 970. We know that there's one instance of the word nymph. These are its beginning and ending character positions. We know there are no instances of lowercase nymph. We can actually use string position to give us a version of our quick display that works on strings. And I'm doing this just to give you a little bit more sense of how we can practice with indexing. So we have a version that works with lists. Now we're creating a version that can work on a single string. We start by giving ourselves a list of the words in our text of the unique words in our text, and the way that we do this is we use union on the list of text words. So this gives us all of the individual words that appear in our text one time. This is a list of strings. If we use the table command, we can step through that list and we can create an association that maps the word to a list of character positions where we can find that word. And I'm just going to show you a little bit of this. It's relatively large, so we're going to take a little bit of a look at this association. So what this shows us, let me just highlight one thing. What this shows us is that the word after appears in a single place in the text from character position 1005 to 1009. The word action occurs in a single place in the text. Those are the two character positions. The word would occurs in two different places, from character position 627 to 631, and from 908 to 912. Now this is an association which has the advantage of letting us look things up. So for example, we can look up where to find the word nymph. If something isn't in the association, we get a key missing error. Now, one of the things that we just solved, one of the problems we just solved in our list version, was finding things to the left and to the right. If we want to do something similar with our string, instead of looking at number of words to the left and to the right, we want to look at number of characters to the left and right. So for example, if I start with a string position of nymph and ask for characters on either side of it, I get an output that looks like this, and here is our word in context. Now one advantage of doing it this way is that we preserve a lot of the punctuation and the formatting and the things that make it obvious that this is, in this case, a soliloquy. In the word list version, the version we did first, we still have the same words. The fair Ophelia, nymph, in thy orisons be all my sins remembered. We still have that context, but it doesn't have the punctuation, the capitalization, the formatting that lets us understand better what's happening here. So one of the advantages of working with the strings rather than working with lists of strings is the preservation of this formatting, which makes it easier and more natural to read the text. Now that we have string position to context, we again can use the map command to map it across lists of, in this case, string positions. And these are the same three examples we just did with word positions. There's one example of the context for nymph. Here's two examples of the context for life. And here's 3 or 5 examples of the context for sleep. We have to scroll to see them, but in separate lines in table form.